All right, so in this lecture, we're going to cover another topic related to logarithms. It's called properties of logarithms. So the learning objective is that we're going to change or determine the solutions of logarithmic form by changing to exponential form. Okay, so you go back and forth between exponential form and logarithmic form. Later, we're going to learn different rules or different properties of logarithms, and then we can use the property to express the logarithmic expression into the sum and difference or product of logarithms, and then write the logarithmic expressions in multiple logarithmic expression into a single expressions. Okay. So first, I want to introduce the technique in order to transform logarithmic form to exponential form. All right, so kind of like in the middle of nowhere right now, but so when you see something like this, you want to evaluate log of base 2 of 32. Is actually this is a different way to write an exponent, right? So what you basically looking for is that, or you ask yourself, what power should I raise to get 32? You see the idea? So 2 to the 5th power will give you 32. You with me on that? So when you see log of base 2 of 32, that means the answer is 5. Okay. So I'm going to write the answer and then I'm going to write the exponential form of this value. Okay. So here, as we discussed that, you ask yourself, what power should I raise to get 32? And the answer is 5. Or in the exponential form, it should be 2 to the 5th power, and that is equal to 32. Now, move on to log of base 3 of 1. Again, you ask yourself, what power should I raise 3 to get 1? 0, right? So 3 to the 0 is equal to 1. Right. So therefore, the answer here is 0, or you can think of this as 3 to the 0 equal to 1. So here I have two answers in the second column. One is for the direct answer of the logarithmic form, and the other one is the exponential form of the first column. Moving on to the third logarithm, log of base 4 of 2. Again, you ask yourself questions: what power should I raise 4 to get 2? One more time. Square root 2. Square root 2. Yeah. Square root of 4, you mean? Yeah, square root 2, right? Yeah, yes. So what power would that be? 1 over 2. Yes. Sorry. Or 4 to the 1/2. Or you can write root 4 equal to 2. Now, number 4, log of base 10 of 1 over 100. All right, so it's not very obvious how to find this value, right? So sometimes you need to rewrite the logarithms a little bit in order to obtain the answer easier. So in this case, what I do is that I'm going to rewrite 1 over 100 as 1 over 10 to the second power. All right, or 10 squared for that matter. So this is equal to a log of base 10 of 1 over 10 squared. So even though yesterday I mentioned that log of base 10 is a common log, you can just write log. but for the practice, I'm going to indicate the base as well. So log of base 10 of 1 over 10 square. This can also be written as log of base 10 of 10 to the negative 2. Right. So 10 square is in the denominator. You want to bring that up to the numerator. Remember the phrase that when you cross the line, you change the sign. Right, so therefore from 1 over 10 squared, you get 10 to the negative 2. And now to find the value of these logarithms, what do? Again, you ask yourself a question that what power should I raise 10 to get 10 to the negative 2? So this is more obvious for us. This is equal to negative 2. Or again, you have 10 to the negative 2 equal to 1 over 10 squared, or equal to 1 over 100. The next one is ln of e to the third power. So ln is log of base e. So the answer is 3. E raised to the third power is equal to e to the third power, of course. So this one is easy enough. The next one is log of base 4 of 1 over 64, very similar to log of base 10 of 1 over 100. You rewrite the logarithms a little bit. So 64 is 4 raised to the third power. Third power. 4 square is 16, right? Times another 4 is 64. So this is log of base 4 of 1 over 4 cube. Or this is log of base 4 10 of 4 to the negative. Oh, sorry. You get too excited. So the answer is negative 3 in this case. Or you do 4 to the negative 3 equal to 1 over 4 to the third power, or this is 1 over 64. Now, what about log of base 2 of 1 over 16? Can you do a quick calculation? Now you relate 16 back to 2, or 1 over 16 back to 2. What do you say? Negative 3? 4. Yeah. So you can rewrite 1 over 16 as 1 over 2 to the 4th power. Or this is log of base 2 of 2 to the negative 4. Or the answer is negative 4. Or you can write this again as 2 to the negative 4, or 1 over 2 to the 4th, 1 over 16. Any questions? And here, log of base 3 of 81, sorry. What power should I raise 3 to get 81? That's too much. So 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth is 81. So 4 in this case. So 3 to the fourth is equal to 81. Again, I have two answers here. One is the direct answer to the logarithm, and the other one is the exponential form of the logarithmic form. Now, can you do log of base 2 of 1 over 8? What is that equal to? So what is that equal to? -3 in this case. Or 2 to the -3 is 1 over 2 to the third power, or this is 1 over 8. Any questions? What about the next one? Log of base 9 of 81 is the answer. 2. Right? What power should I raise 9 to get 81? So the answer is 2, or 9 to the second power is 81. And what about the last logarithms? All right. What is this equal to? -3. So you get a gist of this? Okay. So -3, or 3 to the -3 is 1 over 3 cubed. Or this is 1 over 27. Okay. So this is some, basic calculations of logarithms. Okay. Now, next is some properties related to logarithms. So logarithms is another way to rewrite or to write the exponent. We'll see a little bit later why that is the case. So far, the exercises that we did, we always ask the question, what power should I raise the base to get the answer? Right? So that's another way to think about exponent. So the first property here is that log of any base of 1 power, right, or exponent. So what power should I raise a to get me 1? 0. So the answer is always 0, right? So for the first property, that logs of any base of 1 is 0. Because again, you ask the question, what power should I raise a to get 1? The answer is 0. The next one is log of base a of a. Again, what power should I raise a to get a? Yes. All right. So the first two properties are always going to be the case no matter the base. Now, the next two cancellation property that will show you that the reason why logarithmic function and exponential functions are inverses of one another. Okay. So the first one is log of base a of a to the x is equal to x. All right, so this one is simple enough when you ask yourself question, what power should I raise the base a to get a to the x? Answer is x. Now you remember when we cover in lecture 18, the cancellation property, right, of positive functions, that f of g of x is going to be equal to x, or g of f of x is going to be equal to x as well. Similar to that, in this case, you have logarithmic functions and exponential function. Whatever I say next, probably not mathematically correct, but again, it's convenient for us to understand the concept. So log function and exponential function cancel out, you're left with just x. You with me on that? No, it's not mathematically correct, but it's easy to understand. Good. Now, the second cancellation property is a raised to the log power. So a raised to a log of base a of x is equal to x. Again, in this case, again, it's not mathematically correct to say it, but it's convenient for us. Exponential function cancel out with log functions, you're left with x. So 3 and 4 called cancellation property. Here. So when you learn in college algebra, but or lower level, the math course below pre-calculus, you learn about exponent, how to combine exponents. If you have the same base, so h to the power m times a to the power n, what do you do? What is the answer here? Do you remember? You keep the base and you add the exponent together. Right, so m plus n. Yes, remember. Yes. Okay, good. All right. So now similar to this, gonna move on to the product property. Okay. So the properties say that if I have the log of base a of x times y, let me do this. M times n here. Product, the change to summations. So log of base a of m times n is equal to log of base a of m plus log of base a of n. So that's why I mentioned a few times so far that logarithms or logarithmic form is another way to write power or exponent. Looking for you. Yeah. This. All right. So another formula for exponents, if you have a to the power m divided by a to the power n, you remember the formula, what is this equal to? A raised to what power? m minus n. Okay, so product becomes summation here. And then the next one is the quotient property. Quotient becomes subtraction. So here, if you have log of base a of m over n, you have this equal to log of base a of m minus log of base a of n. Now I have one more formula I want to show you, which is the power property. Now, if I have a to the power m raised to power n, what is this equal to? Do you remember? A raised to what power? M times n. So power become product. Okay, similar to that, and we have power properties. Log of base a of m raised to the power n. This is equal to n times log of base a of m. So power become product. All right. So now we're going to utilize the 7 properties and to solve some logarithmic form. Okay. So the first one is log of base 2 of z to the 3rd power. All right. So log of base 2 of z to the 3rd power. So z to the 3rd power become product. So you bring down the 3, and this is 3 times log of base 2 of z. And this one is the power property. Now, number 2, you have log of base 5 of 25 times x. So here, 25 times x, that is a product. Product becomes summation. So you can rewrite this as log of base 5 of 25 plus log of base 5 of x. You with it? Okay. So that is the product property. So I need one more step here. So in this kind of problem, try to simplify as much as you can. Now, what is log of base 5 of 25 equal to? So the first exercise. Log of base 5 of 25 is 2. Right. So you have 2 plus log of base 5 of x. Number 3, log of base 4 of 4x squared. So 4 times x squared, that is the product. You turn that to a summation. That is log of base 4 of 4 plus log of base 4 of x squared. So here you apply a product property. And I need one more step. Following questions? Now, what is log of base 4 of 4 equal to? 1, yes. And log of base 4 of x squared. So I don't want the power. I'm going to bring it down to become a product, right? So here plus 2 times log of base 4 of x. So what I did is I use the power property. For log of base 4 of 5 times x cubed times y. There are 3 terms that multiply together. That is 5 times x cubed times y. So you're going to separate into 3 different terms, right? Add them together. So here it's become log of base 4 of 5 plus log of base 4 of x cubed plus log of base 4 of y. Again, what you use is the product property. So at this point, you may wonder, should I keep writing the property as I go? You don't have to. This is kind of the first few exercises. Maybe the first time we encounter this kind of problem. So just want to indicate property that I use to go from one step to another step, okay? But moving forward, you don't have to indicate the property. You just need to know what property to use for the step. All right, so log base 4 of 5. There's nothing else you can do. If you don't have a calculator, so just leave it like that. Log of base 4 of 5. Logs of base 4 of x cubed. So reduce the power to a product. The first term is log of base 4 of 5. There's nothing else you can do with that. The second term is 3 times log of base 4 of x. And you use the power property for that. And the last term is log of base 4 of y. There's nothing else that you can do with the last term. Now, the idea of this exercise is that given one or given a single logarithmic form, logarithmic expressions, can you turn that into multiple logarithmic expressions? And we're going to follow the same idea as in example 2 and apply that to example 3. You use different logarithms or properties of logarithms to expand the given expression. So here, number 1, we have ln of 2 over 27. So the idea of this is that you have a quotient. So ln of 2 minus ln of 27. So this is a quotient property. So it looks silly. It is silly, but I just want you to see that the property that I used to go from one point to another point. Number 2, log of base 5 of cube root of 5. So before you apply any logarithmic properties or properties of logarithms, what you do is rewrite cube root of 5 to 5 to the 1/3 power. or power 1/3. So here you rewrite this as log of base 5 of 5 to the 1/3. And the answer is 1/3. Again, you ask yourself questions, what power should I raise 5 to get 5 to the 1/3? Number 3, you have ln of x times e to the x. So there are two terms multiplied together. That is, you have a product. Product, turn that into a sum. So here you have ln of x plus ln of e to the x. Here you have product property. So ln of x, there's nothing else you can do with ln of x. The second term, ln of e to the x, what is that equal to? X. Yeah, so x times ln of e. Right. What is ln? What base is that? Log of what base? E, right? So ln is log of base e. So technically, ln of e is equal to. Not there.
You were closer before.
Yeah, you can see
It's something, my brain's.
All right. So ln is log of ln of x is log of base e of x. All right. So ln of e is log of base e of e. So what is this equal to? Got it? Yep. Yes. Right. So ln of e technically is equal to 1. So even though here you use power property, or you can directly use the cancellation properties, because log of base e cancel out with the actual exponential function. But good. This is ln of x plus x, because ln of e is equal to 1. Number 4, this is the product. Turn that into a summations again. So here log of base a of u square plus log of base a of v cube. Here you use product property. And then the next step is to reduce the power. So this becomes 2 times log of base a of u plus 3 times log of base a of v. What you did is you apply power property. So number 5, can you give it a shot? See what happened. 5 and 6. So most of you get number 5. So this is log of base 2 of A minus log of base 2 of B squared. So this is the quotient property. And you get log of base 2 of A minus 2 times log of base 2 of B. Here, you got this is the power property. Number 6 is another quotient property for the first step. You have ln of square root of 3x minus 5 minus ln of 7. This is quotient property. As I mentioned earlier, in this type of exercises, you want to reduce as much as you can. So here for the first term, you turn the square root of 3x minus 5 into 3x minus 5 altogether raised to the 1/2. Minus ln of 7. ln of 7, there's nothing else you can do with that without a calculator. And then the last step is 1/2 times ln of 3x minus 5 minus ln of 7. ln of 3x minus 5, there's nothing else you can do with that. And here you use again the power property. So for the last two exercises, you are given a single logarithms, and then you want to expand into multiple logarithmic expressions. Now, in the next exercise, what you do is the reverse process. Okay, now you are given multiple logarithmic expressions. Can you combine them together into a single logarithm? Okay. So the first one is log of 6 plus log of 3. So when you see log only, that means this is log of base 10. All right, so log of 6 plus log of 3, that's a summation. You turn that into a product. So this is equal to log of 6 times 3. And we just use the product property. And you got log of 18. Whatever that is. So the idea here is to not to calculate value, but to combine the two terms into a single term. All right. So next one, you have log of base A of 7 plus 4 times log of base A of 3. So before you combine these two expression or two terms together, what you do is you rewrite the second term as log of base A of 3 to the 4th power. Okay. So you're gonna apply the power property first and then the product property. Here you write log of base A of 7 plus log of base A of 3 to the 4th. And this is the power property. Then they have the same, the two logs have the same base. So you can combine them together using the product property. So here log of base A of 7 times 3 to the 4th. Whatever that is. So 3 to the 4th is 81 times 7. 87. 8 times 7, 5, 56. 5, 5, 6, 7. Yeah. You don't have to do the calculation. If you give me this answer, I'll base A of 7 times 3 to the 4. Totally fine. So here, what we did is we use the product property. Number 3. You have a difference, combine them together, you're going to have quotient. So this is ln of x plus 3 over 2x. We apply quotient property. Before, there's a difference here, but before you apply the quotient property, you need to apply the power property first to rewrite the first term. I turn that into log of base 3 of u squared. Minus log of base 3 of v. So again, you use, this is the power property. And this is equal to log of base 3 of u squared over v. And here we just use quotient property. All right, so for the next exercise, example 5, you spend a little bit of time on this. Again, the idea is that now you have multiple logarithms and you combine them together to get just one single logarithm. Gonna give you a few minutes to do it. Six. And some of you notice that they have a different basis for this log of base 2 and this log of base 3. When you have the same base, the different bases cannot combine it together. So the answer to this is not good. So let me quickly do a few problems here, and then I just going to give you the answer for the rest. Okay. So number 1, before you combine them together using product property, you need to turn 3 times log of base 5 of u to log of base 5 of u cubed. Similarly, before you turn 4 times log of base 5 of v to log of base 5 of v to the 4th power. So here you got log of base 5 of u cubed plus log of base 5 of v to the 4th. Again, this is the power property. And then you combine these two terms together. You got log of base 5 of u cubed times v to the 4th. And this is the product property. Number 2, there's no coefficients or there's no constant multiply with the log, okay? It's just log by itself, so it's just basically combine them together, directly apply the product property. Here, it's give me log of a times b squared times c cubed. This is the product property. Number three, all right, because there's a number or a constant multiply with the log, you turn that constant to a power. So here you have log of x to the 1/2 plus log of x plus 1 to the third power. And then you combine the two logs together. So you have log of x to the 1/2 times x plus 1 to the third power. Good? Yes. Yes, you can. Here. Now, number four, there's two approaches to this problem. One approach is that you can distribute the 1/3 into the two terms inside the brackets, and then you rewrite the constant. You change the constant to the power. Okay. That's one way to do that. Another way to do that is first combine the two terms inside brackets. Okay, so log of base 2 of x plus log of base 2 of x plus 1. You turn that into a product. Here you have 1/3 times log of base 2 of x times x plus 1. And then rewrite the 1/3. Instead of the coefficient, you turn that into the power. You have log of base 2 of x times x plus 1 to the 1/3, like that. Now, number 5. Again, you have the coefficients, turn that into the power first before you apply the quotient property. Here you have ln of x plus 2 square minus ln of x. Okay. Now you turn this into a quotient. So ln of x plus 2 square all together divided by x. Number 6, I mentioned earlier, they have different bases, so you cannot combine them together. It's just not available. Number 7, hopefully is straightforward. They have the same basis and there's a difference. So this is the quotient property. I should have started the problem with this. Log of base 2 of x minus log of base 2 of y. It's a lot simpler. Number 8. Now for each term, there's the coefficient. So turn the coefficients into a power before you combine them together. So ln of x cubed plus ln of y squared minus ln of z to the 4th. Now, I'm going to combine the first two terms together using the product property. That is ln of x cubed times y squared minus ln of z to the 4th. And then I apply the quotient property. That is ln of x cubed times y squared over z to the fourth. Okay, we have time. We're gonna have a quiz on Monday, next Monday on this lecture alone. So there will be two questions. One question is that I give you a single logarithms and you expand them. And then the second problem is I have multiple logarithms. Can you combine them